Binary Number Systems Part 2. In this clip we are going to describe decimal to binary conversion. In particular, the repeated division by 2 method. This method is suited to computer programs, so the algorithm that we're going to describe can be used when writing a program to do division, possibly in a language like Python. First, recall some terms when dividing numbers. When we divide two numbers, like for example 9 divided by 4, 9 is referred to as the dividend and 4 is referred to as the divisor. When we divide these two numbers, we get a quotient of 2, because 4 goes into 9 2 times and leaves a remainder of 1, or 1/4 in this case, because we're dividing by 4. Here's the algorithm. Step 1, divide the number by 2 and record the remainder. Step 2 is check if the quotient is 0, and if it's not, replace the dividend by the quotient and go back to step 1. Repeat steps 1 and 2 until the quotient reaches 0. Then move on to step 3. At step 3 we just copy out our remainders, starting with the last one recorded, and this is our binary equivalent of the decimal number. Here's an example. Convert 65 into binary. 65 divided by 2 is 32, remainder 1. So replace our dividend 65 by 32 and repeat the step. 32 by 2 divided by 2 is 16, remainder 0. So replace our dividend 32 by 16 and repeat the step. Carry on like this, recording the remainders until we get to this stage, this last stage, where we get 1 divided by 2 equals 0, remainder 1. Because our quotient has now reached 0, it's time to stop this process and write down our remainders in reverse order. From the most significant bit is the last bit recorded to the least significant bit, which is the one we first started with. So 65 in decimal is equal to 1000001 in binary.